Okay, so let's talk a little bit about dilutions. Dilutions are pretty straightforward. The formula is very simple. It's molarity 1 times volume 1 equals molarity 2 times volume 2. The problem, or where I can make it more complex, is how I define or tell you about the volumes. So if we look at the first one, I don't give you a volume. It says equal volumes. You can choose any number you want. So if you choose 1 liter, then it would be 1 liter of water. But you also have to think about what's physically happening. So here's my container, and let's say it has 1 liter of 3 molar KCl. Then I have another beaker over here. It also has 1 liter, but it's H2O. And when I then put those two together, and I pour this volume into here, what's my new volume going to be? Well, the V2 is going to equal 1 liter plus 1 liter, which is 2 liters. So now we have volume 2, we have molarity 1, we have volume 1, and we just solve for volume 2. And so it would be, molarity 2, molarity 1, volume 1 divided by volume 2. And then that would give us our new molarity. So that's pretty easy, and I think you can handle those without me doing anything else. So let's get down to some down here where we're adding a certain milliliters of our solution and so many milliliters of water, and you can just add those two together to get volume 2. So that's pretty much the same thing. I've just given you specific numbers. Here, however, like B, I'm giving you a volume and a molarity, another volume, but it's not water, it's another solution. So this one, we're going to have to do moles of solution A plus moles of solution B is going to equal moles total. And so to get moles of A, I'm going to take that many milliliters and put it into liters. So that's 0.045 liters times 3.6 moles per liter. And so that will make liters cancel out. Plus, I'm going to do the same thing with my second solution, which is 71 milliliters, 0.071 liters, 1 liters, times 6.2 moles per liter. And that'll give me my total moles. And whatever that answer is, I'm going to now divide by my new volume, which is going to be 71 plus 45, or actually 0.045 plus 0.071 equals, wait, something was already in there, 0.041 plus, 0.045 plus 0.071 equals 116, or 0.116 liters. And so you can do that math and that math, add them together, and then do the division. So there is one a little further down that has a third type of problem. Oh, and on here we need to eliminate 8, 9, we need to eliminate 10, and then eliminate 13. Just a typographical error. So there's one, and we want to reduce its concentration to this and this. What volume? Okay. So this handles most of it. There's one where you have to reduce the volume, and that you're just going to do, oh, here it is. So we have this molarity, but we want to make this molarity. So we want, oh wait, we have this molarity, but we want to make this molarity. So we need to decrease the volume. So you need to calculate how much water to evaporate. And so you're going to calculate the new volume, but it's just going to be smaller than the original volume, then subtract. I think you can handle it. If not, ask me about that one before or after school or in class if you have chance at lunch or something like that. So basically, the calculations are pretty straightforward. I don't think you'll have much trouble with it. But like I said, if you have trouble, come see me. Thanks.